Hello everyone, welcome to the video lecture series on probability and random variable. I am Professor Mayur Gohil. In this video lecture, I shall be giving you details regarding probability and random variable. So let us see what is the first thing regarding random variable. So let us first understand the definition of random variable. Now, though the name over here is random variable, but it is a function. Now this is a very strange thing in the world of mathematics or statistics. So let us see what it is. A function capital X which assigns one and only one real value to every sample point S of sample space S is called a random variable. Now, basically, what do we mean to say here is that X is a function that is giving a real value out over there. Okay, it is denoting some real value. That is what it means. So if you have X of S over here, okay, so it is giving some value out over here. It can be let's denote it by small letter x, and this small letter x is a real number. Okay, so it belongs to the set of real numbers. This is what is the meaning here basically. Now what we need to understand regarding this is only the following thing, that remember at the back of the mind that random variable is a function. This is what we have to remember. Now another thing is that a random variable is always denoted by capital XYZ. That is the notations that are used generally. Okay, so and it depends upon the question. Accordingly the function will be defined over there. Okay, and in short, random variable now onwards will largely be written as r dot v dot. Okay, so whenever you see r dot v dot, remember it is a short form of random variable. Okay, now we go for types of random variable. There are two types over here. The first type is that there is a discrete random variable, and second type is continuous random variable. Now what are their definition and how do we understand them? The first, I'm taking a very simple and a very easy form of definition. The technical mathematical definitions are quite strict in their language, and their mathematical notations are there. We won't go into that detail, but we will see how to get the whole concept into use. Okay, so for that usability purpose, the definitions that we are going to take up are the one which are more simple versions which can be understood even by a layman. So a discrete random variable, uh, a, a random variable is said to be a random variable capital X is said to be discrete if it takes integer values. Okay, and a random variable capital X is said to be continuous if it takes values in an interval. Now this will be more clear when we see examples related to it, and different types of random variable and their understanding will slowly seep into us once we solve more and more example. So for time being, these are the definitions, so you can understand them and digest them. So you can take a snap of this slide. Okay, take a screenshot of this and you can refer it again and again. Now let us go for more detailed concepts related to random variable. Now, for discrete random variable, we have something called as a probability mass function. Okay, so we have probability mass function. Now, what is probability mass function? It is in short denoted by PMF. So let us see. Let x be a discrete random variable that takes values x1, x2 up to xn. Now these are integer values because x is a discrete random variable with corresponding probabilities as p of capital X equal to xi is equals to small p of xi equal to small pi, where I equal to 1, 2 up to n. Okay. Then the table, then in tabular form, the probability mass function is given as follows. So here I'll draw the table. So it is capital X equal to X. So here we will have P of X equal to X, which is small p of X equal to P. Okay, so now how does it look here? So it is here, it is x1, then this will be p of X equal to x1, and this is small probability. It is just like notational way of writing this way. Now see, mathematicians and the statisticians, when they develop all these things, that time there were not too many of computer advancements were not there, so all these things were manually done. So they kept it all, with the notations they made all. So all this is for that purpose. And mathematics, when you do, or statistical, this is all statistical mathematics or mathematical statistics. So when we try to do all these things, we try to keep it very precise, because later on the whole process that we want to do is based upon all this notation. So we keep it very precise and brief all throughout. So here it is x2, so this will be p of x2 equal to p2. Okay, and then this is goes on up to xn, and so similarly all this thing will be going down up to probability of x equal to xn equal to p of xn equal to p of n. Now here this is total. So this total, if you want, this total will be 1. It has to become 1, otherwise there is some mistake that we will see in the what we call the property of this. But then this is there, and this total is generally optional, it's not written, but if you calculate, that is one way to understand whether the table is correct or not. Okay, so this is the table of probability mass function. Now here itself we can immediately jump into one very important topic of properties of probability mass function. So we write here properties of probability mass function. Okay, so the first property is here that every probability is p of x equal to xi. Okay, I'll just directly call it as pi. This probability should be greater or equal to 0, and it should be less equal to 1. Okay, all probability, as we know that every probability answer should be between 0 and 1. This is the first probability, then this happens for every I. Okay, now second property here is that the total of all the probability should become 1. So This is here. Now this is what is called probability mass function, and these are the properties of probability mass function. Now here another concept is also there. Let me introduce that concept to you, that how it will work. The concept is of distribution function or cumulative distribution function. Cumulative distribution function. Okay. Now this concept is ideal and very important, a slightly advanced part. Now this concept works for both discrete as well as continuous random variable. We will see for discrete random variable first. Now it is generally denoted by capital F, and let us see how to work about it. So it says here, let x be a random variable with PMF, p of x equal to x, then CDF, or then cumulative distribution function, which is in short written as CDF, is denoted by capital F suffix x of x and given by the following formula, given by capital F of x. This is the main definition. Okay, the definition is this: P capital X is less than or equal to small x. Now when capital X is discrete random variable, this formula of P of it is the same formula, but now what does it do is it becomes the formula on simplified version. It becomes P of x equal to x here, where capital X is less than or equal to x. This is how it runs. So it is basically the less than cumulative function. So you can just remember here, it is less than cumulative distribution that when we make, that is what we have to do. So here it is, you can write down a note here for discrete RV, capital F of x is less than cumulative distribution. Okay, this is what it is. Now, so we have seen what is a probability mass function. We have seen what is the properties of probability mass function, and we have seen what is a cumulative distribution function. So let us take up an example related to the topics that we have seen. So here we have the question that for the following function of x, find the value of k such that the function is a PMF, or also find the CDF of x. So let us see how to solve such a kind of a question. Now the question is very easy. We write your answer as follows. Okay, so we in order the function to be PMF, it must satisfy summation p of x equal to x as 1. Okay, so the total of all probability should be 1. So what we do now here, we add the probabilities that we see. So the probability of x equal to 0 plus probability of x equal to 10 plus probability of x equal to 15, which is going to be 1. Total of probability should be 1. So here the probability of 0 is k minus 6 over 5 plus 2 over k plus 14 over 5k, that is 1. Now on simplification, what do we see here? It is phi k times k minus 6 plus 10 plus 14, that is equal to 1. Okay, now we simplify for this. So what do we go and get here is k square minus 6k plus 24 is equals to 5k. Okay, on solving further we get that k square minus 11k plus 24 is equal to 0. On solving further this quadratic, it is a quadratic equation, so we get here k minus 8 and k minus 3. These are the factors, so the roots are going to be k is equals to 8 or k is equals to 3. Now both roots are positive. Now either one of the two answer is going to be the answer, the valid answer. So let us see which one is valid. So when k is equal to 3, p of x equal to 0 is equals to 3 minus 6 over 5. Therefore p of x equal to 0 is minus 3 over 5, which is less than 0, which is less than 0, and that is not possible, right? Because all probabilities should be between 0 and 1. That is one of the property of the probability mass function, which is not possible as all our answers should be between 0 and 1. Hence k is equal to 8. So now once we have concluded the answer that k is 8, we will now write the correct PMF with the value k. Okay, so we write here the required PMF is capital X equal to X. Now we are, instead of writing it horizontally, I am writing a vertical table because that is more convenient. P of X equal to X, and now we write the values 0, 10 and 15 are the values that X is taking, and here P of X is equals to X. Now when it is 0, we are going to get k value is 8, so 8 minus 6 over 5 is 2 over 5, then 2 over 8, which is going to give me the answer as 1 upon 4. Okay, so here it is 1 upon 4, and the last answer for 15 is going to be, it is going to be 14 over 40, so that is finally it is going to become 7 upon 20. Okay, so this is the probability over here. Now even if we check it manually, if we don't write the total also, maybe you can just check that this total is going to become 1. Okay, 2 by 5 plus 1 by 4 plus 7 by 20, this total is 1. Okay, so that's how this whole thing works, and this is the probability mass function that we wanted. Now they have told us to write the CDF of X. Now CDF of X is very easy. What generally students do, they just add one more column over here and write that. It is absolutely fine, but for the sake of explaining, I'll be writing the whole thing again and helping you out. So let me write down the PMF again. Now this is the required PMF. In order to find CDF, what we do here, we write the column over here, that is f of x equal to x, which is, now we write this px less than equal to x. This is the main definition over here for capital F. And for PMF, from PMF we will get the answer for CDF. So what we do, it's less than cumulative as we had written, and X is a discrete random variable over here. Now why X is discrete random variable? Because here X is taking integer values 0, 10, 15, they are integer, so that's why it is a discrete random variable. So as per that formula that we had discussed in the theory right now, so we write over here, it will be, first thing is 2 by 5, the next one answer will be 2 by 5 plus 1 by 4. Okay, so the answer over here is going to be 13 by 20. The next answer is going to be 1. How that answer has come? Because if we add the next year, it is going to be, if we add 13 by 20 to 7 by 20, we'll get 1. 13 by 20 plus 7 by 20, the answer is 1. Okay, so basically what it is happening is that we have to just take the first value as it is, and then you have it over here, and then the whatever answer you get here, you add it and write here. Okay, you add that to the next probability, you get that, and then whatever is that new answer, you transfer that new answer on the other side. Okay, and then you again add it with the next answer, and you will get your final answer, like that. Okay, and at the last, whatever is the last uh, probability, it has to be 1 because it is cumulative. Okay, so here we write here, so in exam also you can mention like this, the above in the above table column 3. Okay, the third column, or we can call it third column shows the CDF of capital X. That is what it is. Okay, so this is the CDF of the random variable X. I hope you have understood the concept that I had tried to explain you here. Let us take up one more example in order to understand how to do the question related to probability mass function. Okay, this is the question over here that we are taking up to find the value of k for the following PMF, and we have some other questions to find the probabilities. Let us see how to do them. Now here I would like to tell you that here a question which is given in the third part, okay, this is slightly important. There are two ways to do this, so I'll put a star over here to this, so we will be able to get that. Even for the second one there are few ways to do that, we will see it later. Okay, when we deal with detailed versions of properties of CDF, but now since CDF is introduced to you in just recent video, in this video I would like you to understand how to use CDF definition for the third case. So let us see how to go about it. So we write the answer here. For the first part, it will be, since it is a PMF, total of all probability P of X equals to X is going to be 1. Okay, all probability added up should give you 1. Now this here, let us add them up. Let us see how to simplify this. Now we can clearly see that the LCM here is going to be 20k as the LCM, so let us do that. Therefore we will divide the entire thing by 20k. Okay, now when we have 20k, so here in the numerator the first term will become k square, then here it will become 8, here it is going to become 4k square, right, and here it is going to become 2k, so it will become 2k square, and here it is going to be 4 times k minus 1 equals to 1. Now let us simplify this. We'll write in this short corner. So what we get here is 7k square plus 4k minus 4. See, here it is 8 and here there is minus 4. So when you do the subtraction of minus 4 and 8, it will give you plus 4, which is equal to 20k. So 7k square minus 16, okay, plus 4 is equals to 0. Now on solving here, so k is equals to 2 or k is equals to 2 by 7. Now comes the most important part, which of the two value is correct. Let us see that which of the two value is going to be correct. Now let us do little bit inspection, that if we put over here in the probability for x equal to minus 1, okay, let us see this. The moment I put k equal to 2 by 7, what happens? So when k is equal to 2 by 7, what happens to probability of x equal to minus 1 will become 2 upon 5 2 by 7, right? So this is basically 7 upon 5. Okay, therefore probability of x equal to minus 1 equals to 7 upon 5, which is greater than 1, which is not possible. Hence k equal to 2 by 7 is discarded. You must justify, because there are two choices. If you admit the two choices, why are you admitting? Or if you discard either one of the two, why are you discarding the one? Okay, that reason is extremely important because it's going to be mathematics. You cannot shoot in dark over here. You have to be very foolproof with your choices, and you have to have a foolproof reason behind it. So now, therefore, we are now left with only one choice, k is equals to 2. So we write here the required PMF is, okay. Now what about the first probability? When x is minus 2, the value over here, it is going to be 2 upon 20. 2 upon 20 is same as 1 upon 10. When it is minus 1, the probability is going to be, so it is k is 2, so it is 1 over 5. So you can directly get that answer here, 1 over 5. When k is 0, okay, here the answer is again, it's going to be 2 over 5. So it is 2 over 5. The next answer for 10, it is going to be 1 over 5. So the answer here for 1. Okay. So basically, how are we getting all these answers? It is, this is 2 over 10. Okay, this is what it is. Here 2 over 5 is simple. Here it is going to be 2 over 10 again. So that's how we are doing it. Now the last one for here, it is 2. We write here 2 is equals to, for 2 the corresponding probability is going to be 1 over 10. So it is 2 minus 1 over 10. So that is basically it is 1 over 10. Now this is the required PMF. If you don't want to show these calculations, if you do in your calculator, that's fine. If you write the final answer, that is very well expected. That is what is expected. But here I just showed the basic calculation so that if anyone is not aware how to get it done, you are clear about it. Okay, you may write your total or you may not write total, it is okay, but it's a good practice to write the total. So total of the probability is all the probability added up together, it's going to be 1. Oral addition of numbers of probabilities can also get you the answer. So this is the table that we have. So let me make it little precise, and we are done with the PMF, the correct PMF that what we wanted. Okay, now this is the answer. Now they are asking us to find the value for probability which is between -1 and 2. That we can do it straightforward. So second case is to find the probability between -1x less equal to 2. This means, so here the values are 1 by 5, 2 by 5, 1 by 5 and 1 by 10. So is 1 by 10, so added up 9 by 10. Okay, that's the answer. So the answer is 0.9. This is the answer. Now let us understand what is the probability, what it is, the third one. As I told you, this is the important case, and I would like you to understand it in both the ways which is there. So here the probability for x less than 1, less than or equal to 1 is asked to us. So probability x is less than or equal to 1, this can be seen in this manner. The first one, I would like to say that this is, when we are doing this, probability x is less than or equal to 1 is same as 1 minus probability x is greater than 1. Okay, this is using the complement event kind of thing. So this is one way to do. Now probability x is greater than 1 is going to be, so that is basically probability of x equal to 2, and that is 1 minus 1 by 10, and that's going to be 9 by 10. Okay, so 0.9 is the answer. This is one way of doing it. There is one more way which can be dealt, and I want to deal that also. This is method 1, or I can write style 1. Okay, it's slightly, this is method 1 over here. Okay, this is method 1 that we got. Now what is the method 2? Method 2, for method 2 we would need CDF of the PMF that we have calculated. So let us just calculate the CDF here for understanding purpose. So we will write here the CDF. Okay, so CDF. Okay, so I'll just write here, and the table over here is f of x, which is p of x less than or equal to x. That's the definition. Okay, so for CDF we need, the first value is written as it is 1 over 10. The second value you add it up. Okay, you add it with the second part. So perform the addition with this. Okay, add them. So the moment we add them, we get 3 over 10. Okay, so the answer is 3 over 10. The next one, when we add them, 3 over 10 and 2 by 5 is going to be 7 by 10. Here it is 9 by 10, and the final answer is 1. Okay, so this is the CDF that we have here. That's how it is done. Now this CDF, when we are doing, please be very careful that at the end your answer must come 1, otherwise you have made some mistake in addition of the column over there. uh, you be careful while doing the addition. Now, what I wanted to discuss in the light of CDF, the formula of CDF. The formula for CDF is this. I'll now write the method 2. It says capital F of X is X, which is probability capital X less equal X. Now, if we put here X equal to 1, if I put small x equal to 1 in the formula, it basically gets converted to 1. So it is essentially what we have to know, that p of x is less than equal to 1 means that it is asked for CDF, and that is CDF of the x when it is value is 1. So this means f of x, f of 1, which we had already calculated, it is 9 by 10. From CDF here we can see. Okay, so this is, if you want to know the names of this is f of x, f of minus 2, this is f of minus 1, this is f of 0, this is f of 1, and this is f of 2. Okay, this is how it is. So once we understand the notations carefully, you can use the advanced concepts if you are very well versed. Right now the topic, there are very small values are there, but sometimes many values are there, then it is easy to use what is CDF concept. Okay, so this is what I wanted to explain using CDF. Okay, this is how using CDF you can also calculate the probability and some probabilities which are in that format that can help you to get the answer. So here the answer was 9 by 10, which is 0.9. I hope you have followed the example that we have seen here, and you are able to understand the concept of finding the value of K for PMF, how to understand which value is correct in a PMF, how to calculate the probability, and how to use CDF for the discrete random variable. Okay, I have tried here explaining all these concepts. I hope you have followed them. Please hit like button, subscribe to my channel, share the video with your friends, those who find this topic useful. I will soon see you with another example and different concepts. Till then, keep solving good amount of mathematics. Thank you.